Hello everyone. In last lecture we have learned the concept correlation. Now in today's lecture we are going to learn the concept regression. In this topic we are going to learn what is meant by regression, what is the relationship between correlation and regression, and why we use the regression. Regression is the functional relationship between the two variables and correlation is the interrelationship between the two variables. The relationship between the dependent and independent variable may be expressed as a function, and such functional relationship is termed as the regression. When there are only two variables, the functional relationship is known as the simple regression, and if the relation between the two variables is a straight line, is known as the simple linear regression. Regression is useful for the prediction purpose. Regression is used only when there is the correlation exists between the variables. If we know the value of one variable, then we can easily predict the value of another variable by using the regression. But one condition is that regression is applied only when there is the correlation exists between the variables. So this value is predicted by using the equation of straight line. Y is equal to a plus b into x. Okay, so if the correlation between the two variables is perfect positive or perfect negative, then we can easily predict the values of a and b, because only the one line is passing through the points. So we can easily predict the slope and intercept. But if there is the highly positive or the low degree positive correlation exists between the variables, then there is the several line passing through the point. Then how to choose the best line? Then for that we use the least square principle for finding the values of a and b. There are two regression lines, y on x and x on y. First of all, we see the regression line y on x. What is mean by regression line y on x? Y on x means y is depends on x. That means here the y is the dependent variable and x is independent variable. What is the regression line y on x? Y is equal to a plus bx. This is the equation of straight line where y is the dependent variable and x is independent variable. What is a and what is b? A is the intercept parameter and b is the slope parameter. If we know the value of a and b, then we easily calculate the or predict the value of y by using the regression. But this regression is useful only when the correlation is perfect positive or perfect negative between the variables. But if there is the moderate positive or moderate negative or high positive or high negative correlation exists between the variables, then there is the several line passing through the point. Then how to choose the best line for finding the value of a and b? So for finding the value of a and b, in this condition we use the least square principle. So least square principle y on x is y minus y bar is equal to byx into x minus x bar, where byx is the regression coefficient y on x and x bar is the arithmetic mean of x variable and y bar means arithmetic mean of y variable. How to calculate x bar, y bar and byx? X bar is calculated as sum of all observations of x divided by n, that is total number of observation, and y bar is calculated as summation y upon n, where n is the number of observations, and byx, that is the regression coefficient y on x, formula is summation xy upon n minus summation x upon n into summation y upon n whole divided by summation x square upon n minus summation x upon n bracket square. What is mean by summation xy? Summation xy means take the total of all the values of x into y, that is the total of column of x into y. What is summation x square? Means x square column sum, that is the sum of all the values of x square. Now then the regression line x on y. X is equal to a plus by. Here regression line x on y means x is depends on y. That means here x is the dependent variable and y is independent variable. And similarly a is the intercept parameter and b is the slope parameter. If either perfect positive or perfect negative correlation exists between the variables, and we can easily predict the value of a and b, that is slope and intercept. But if there is the positive or negative correlation, that is moderate or highly positive correlation exists between the variable, then several line passing through the points. So how to choose the best line is the problem. So least square principle is used for finding the value of a and b in this condition. So the least square principle x on y is x minus x bar is equal to bxy y minus y bar, where x bar is calculated as summation x upon n and y bar is calculated as summation y upon n, and bxy is the regression coefficient x on y. So formula for finding the bxy is summation xy upon n minus summation x upon n into summation y upon n whole divided by summation y square upon n minus summation y upon n bracket square, where small n is the number of observations. Let's see one example from the following data on consumption of fertilizer nitrogen for paddy yield y. Feed the regression line y on x and estimate the value for paddy yield when x is equal to 15. From the following data on consumption of fertilizer, that is variable x, nitrogen for the paddy yield. Here the paddy yield is the y variable. Feed the regression line y on x. That means here the paddy yield depends on the consumption of fertilizer nitrogen. So, and then estimate the value of paddy yield when x is equal to 15. Here we need to fit the regression line y on x. That is y is equal to a plus bx. Okay, there is the correlation between the paddy yield and consumption of fertilizer nitrogen. First we need to find out the value of a and b by using the least square principle. Okay, so here we are given the x and y values. X values are 3, 4, 8, 4, 5 and 6, and y values are 9, 7, 16, 8, 12 and 14. First make the column x into y and then x square. So what is mean by x into y? Just multiply the value of x to the corresponding value of y. So 3 into 9, that is 27. Then 4 into 7, that is 28. Then 8 into 16, that is 28. Then 4 into 8, that is 32. Then 5 into 12, that is 60. Then 6 into 14, that is 84. Now make the column x square, that means just squaring all the values of x. What is the first value of x? 3. So 3 square 9, then 4 square 16, then 8 square 64, 4 square 16, 5 square 25 and 6 square 36. Now take the total of all the values, all the column values. Okay, so what is the summation x? Here the column is x, so summation x is 30, that is 3 plus 4 plus 8 plus 4 plus 5 plus 6. Then summation y is 66, summation xy is 359 and summation x square is 166. So first calculate x bar, then y bar and then byx. Here we need to fit the regression line y on x. Okay, so what is x square formula? Formula is summation x upon n. What is summation x here? Summation x is 30. So 30 divided by n will be the total number of observations. Here we are given total 6 observations. 1, 2, 3, 4, 5 and 6. So n value is 6. So x bar is equal to 30 divided by 6, that is 5, and the y bar formula is summation y upon n. Summation y is 66, n is 6. So 66 divided by 6, that is 11. Now the byx. What is the formula for calculating the byx? Summation xy upon n minus summation x upon n summation y upon n whole divided by summation x square upon n minus summation x upon n bracket square. Just plug all the values, that is summation xy, summation x, summation y, summation x square and n. Summation xy value is 359. divided by n is 6, then summation x is 30 divided by n is 6, then summation y is 66, n is 6 divided by 6, whole divided by summation x square is 166, n is 6, minus summation x is 30, n is 6, bracket square. 359 divided by 6 value is 59.8333 minus 30 divided by 6, that is 5. 66 divided by 6, that is 11. So 5 into 11, that is 55. Divided by 166 divided by 6, that is 27.6666 minus 30 divided by 6 is 5. 5 square, that is 25. Then 59.833 minus 55, that is 4.833 divided by 27.6666 minus 25, that is 2.6666. So 4.833 divided by 2.666 is 1.8125. Now the least square principle y on x formula is y minus y bar is equal to by x minus x bar. So just plug the value of x bar, by x and y bar in the formula. So y as it is, y is the variable, y bar value is 11. So 11, by x value is 1.8125 into x variable. So write down as it is and x bar is 5. Now the question is, feed the regression line y on x and estimate the value for paddle, that is estimate the value of y when x is equal to 15. Now just plug the x value is equal to 15. So y minus 11 is equal to 1.8125, x is 15, 15 minus 5, that is 10. So y minus 11 is equal to 1.8125 into 10, that is 18.125. So y minus 11. So take 11 to the right side. So here in left side 11 is negative. So in right side take the 11 right side, so we will get it positive. So y is equal to 11 plus 18.125, that is 29.125. That is the paddy yield is 29.125 if the consumption of nitrogen is 15. So this regression is useful for the prediction purpose, we proved. Okay. Now the second example is, feed the regression line x on y and estimate the value of x when y is equal to 20. Procedure is similar, but here feed the regression line x on y and estimate the value of x when y is equal to 20. The procedure is same. First make the column x into y, then y square. In regression line y on x we need the column x square, but in regression line x on y we need the column y square. What is mean by x into y? Just multiply the x value to the corresponding value of y. So 3 into 9, that is 27. Then 4 into 7, that is 28. 8 into 16, that is 28. 128. Then 4 into 8, that is 32. Then 5 into 12, that is 60. And 6 into 14, that is 84. Now y square means just squaring all the values of y. So 9 square 81, 7 square 49, 16 square 256, 8 square 64, 12 square 144 and 14 square 196. Now take the total of all the columns. Summation x 30, summation y 66, summation xy is 359 and summation y square is 790. Now just plug all the values in the formula of x bar, y bar and bxy. So x bar formula is summation x upon n. Here the summation x is 30 and n. Number of observations we are given in example is 6. So 30 divided by 6, that is 5. And y bar is summation y upon n. Summation y value is 66 and n is 6. So 66 divided by 6, that is 11. And what is the formula for calculating the xy? Formula is summation xy divided by n minus summation x upon n into summation y upon n whole divided by summation y square upon n minus summation y upon n whole square. Here the summation xy is 359 divided by n is 6 minus summation x is 30, n is 6, summation y is 66, n is 6 whole divided by what is summation y square? 790, n is 6 minus summation x is 66 divided by 6 its square. Then 359 divided by 6, that is 59.833, minus 30 divided by 6 is 5 and 66 divided by 6 is 11. So 11 into 5, that is 55. Now the whole divided by 790 divided by 6, that is 131.6667, minus 66 divided by 6, that is 11 square, that is 121. Now 59.833 minus 55, that is 4.8333, divided by 131.6667 minus 121, that is 10.66667. Then 8.333 divided by 10.6667, that is 0.4531. Now just plug the values of x bar, y bar and bxy in the least square principle x on y. So formula is x minus x bar is equal to bxy into y minus y bar. X is write down as it is because x is variable, minus x bar value is 5 is equal to bxy value is 0.4531. Y is variable, so write down as it is, and y bar is 11. The question is, that is example is, feed the regression line x on y and estimate the value of x is when y is equal to 20. Now just put the y is equal to 20. So x minus 5 is equal to 0.4531, y is 20, so 20 minus 11. So 20 minus 11, that is 9. So x minus 5 is equal to 0.4531 into 9, that is 4.0779. So x minus 5. So take the 5 right side. So 5 plus 4.0779 is equal to 9.0779. So this regression is useful for a prediction purpose. Sorry, here is the x. So if y is equal to 20, then our x value is 9.0779. So this is the regression line, and regression is useful for the prediction purpose. But one condition is that regression is applied only when there is the correlation exists between the variable. So first we need to check whether the correlation exists between the variables or not. Thank you.